new title. Is that the title? Uh-oh. So we have two possible titles. There's the one on the screen, and I also have issuers. Want Fido Auth in a merchant's checkout? Just ask. And our presenters now are Paul Miller, the CEO of mSIGNA, and George Tuvel, the CTO. So welcome, gentlemen.
Thank you, David. Thank you. In the event opener, Andrew Shikiar explained how payment is a Fido accelerator. We're all seeing that payment, authentication, and identity innovation arcs are coming together in the products out there in the field. But unfortunately, the industry's ad hoc journey to this secure commerce destination is just not working. So today we're going to explore how Fido, with its presence in OEM, broad OEM support, clever technology, and easy user experience can help guide this path. The needs for the ecosystem are very straightforward. Merchants want it easy. They want an easy integration. They want an easy checkout experience. Easy, easy, easy. Reliant parties want safe payments. They don't want the fraud. The challenge, as David Visa yesterday said, the challenge is that payment is a complicated landscape with a lot of moving pieces. Quite honestly, there's a lot going on behind that buy button. Where authentication is typically a one-to-one relationship, consumer logging into their web service, payment has three relationship domains. The merchant and the consumer shopping experience that we all know, the merchants and issuing banks, which is a really complex path through payment service providers, acquiring banks, payment networks, and finally, like Visa and MasterCard, and then finally over to the issuer, and then the issuer's relationship with the card holders. Getting the right data between these parties, unfortunately, is not straightforward. Three-domain security, or 3DS, is the industry standard for exchanging this data. 3DS is led primarily by Visa and MasterCard, and it's also called out directly with Europe's SCA. To complicate the problem further, web payments allow the browser to connect directly to the client and get the data that the trusted third party needs. App-based payments do not allow that connection. In an app-based payment, the merchant integrates an SDK, the SDK gathers some data, and then that's passed on to the issuer for their decision processing. In summary, you get a different checkout experience, you get different flows, you get a different set of integrations, and you get different data sets that don't even support things like dynamic device identifiers and things like that. So what we've proposed, mSIGNA has proposed to Fido, to EMV Coast, 3DS, as well as W3C, is an effort to harmonize the payments and address these market needs. We're proposing a standard client API and a universal SDK. The client API, or CAPI, is a consistent interface between the cloud and the clients. The universal SDK, or USDK, is a consistent interface between the device and its data, regardless of the device. Together, CAPI and the USDKs provide a consistent interface between the web services and the data that they require from the client, specifically authentication data and payment instructions from the user. CAPI enables TTPs to declare these data instructions and include that in the exchange so that the trusted third party can get the data from the environment. There's about a dozen CAPI data instructions for SCA compliance, for things like dynamic device identifier, one-time password, behavioral biometrics, and of course, FIDO authentication. Using these instructions, a TTP can request the information from the merchant environment and receive that information in 3DS as part of the initial frictionless flow. This enables the enhanced data to be sent over with the transaction data and remove the need to do challenges or out of bands to be SCA compliant. The same CAPI data instructions can be used by a delegated authentication party, the party of the merchant authenticating. They can send these instructions directly to the CAPI, the client API protocol service. Even without a banned login authentication for the issuer, the same CAPI instructions can be used to talk to that issuer device. We have a partner here in the audience that's actually doing that right now through a single implementation, they can allow their issuers to log in to the app. They can allow their issuers to provide step-up or authentication services. And this crew, Simple ID, does one integration, and they get all of the data context from any USDK device. Since the CAPI instructions are declared by the TTP and passed to the merchant for execution, this is all first-party data exchanges. There's no risk of a browser blocking a third-party data event. And that's obviously very, very important as we go forward. The second half of that CAPI equation is the USDKs, Universal SDKs. The USDKs, quite honestly, are the savior for merchants. Merchants are shell-shocked. They're being asked to integrate Fido SDKs, 3DS SDKs, SDKs for device identity like threat metrics, SDKs for behavioral biometrics, SDKs for W3C commands, SDKs for secure remote commerce. They just can't take it. With a universal SDK, a merchant could do a single integration and get access and benefit of all of those standards and requirements, including support for future versions like EMV 3DS version 2.3. mSIGNA is, as I said, working with Fido, W3, and EMVCo to explore the standardization of these 5 CAPI and USDK protocols that abstract the cloud from the client, providing a consistent endpoint that's easy, one-time integration, regardless of the client. That includes potentially IoT. If data is the new oil, the USDKs are the wells that find that data, and CAPI is the pipeline that ships that data from the client back to the web services that require it. Now, CAPI and USDK protocols use and enhance the W3C WebAuthn and secure payment protocols. For example, when a USDK is in an app-based checkout, it can call out to a browser, conduct a WebAuthn in order to enable Fido as part of that app checkout done through a browser. In addition, when using Chrome, as the Intersect crew said yesterday, when using Chrome, USDK can call an SPC for cross-origin credentials, and again, provide a very consistent, easy checkout. When SPC is not available, CAPI data instructions allow trusted third parties to request a credential be created and stored within the client, within the merchant, origin, or app. So that's a trusted third party, reliant party's credential being created and stored in the merchant's origin or app. This CAPI embedded credential is an always available Fido checkout option. It aligns with the SPC concepts of merchant presentment and reliant party validation, and gives the industry a complete, easy, SCA-compliant Fido checkout experience without the user interruptions. And that's the gold standard, as we all know. Overall, CAPI and USDK support a range of authentication methods. These can be used directly for SCA compliance, or they can be used as part of the registration process for creating a Fido credential and a Fido checkout. George is going to come up here and show us a demo that uses 3DS, the CAPI data instructions. Sorry, I'm giving the mic guys a headache. The 3DS CAPI data instructions, USDK and Fido, to show a reliant party requesting extra data for SCA compliant, as well as for Fido registration. He's then going to create a CAPI embedded credential, a TTP's credential within the merchant environment, and use that as a checkout. George?
Thank you, Paul. Okay. Hopefully my screen is visible. Is the browser visible? Oh, there we go. Thank you. Okay. So this is our payment simulator platform, and it is a complete end-to-end platform. So what I mean by that is from the merchant checkout environment here, you're looking at the e-com shop, all the way through to the relying party, which is the issuer in our example here. So this the shop here is it's EMV 3DS v2.2 compliant. So it's running a JavaScript SDK. And then behind the scenes, we have a 3DS server, a directory server at the payment network, and then an ACS, which is at the issuer, at the relying party. The issuer is also running a Fido server and the JavaScript SDK is WebAuthn enabled for FIDO authentication. So what we're going to show you is a FIDO registration and a FIDO authentication with the relying party being the issuer, but occurs within the merchant origin or the merchant first-party context, which is the web shop here. So a key point, or the main point here rather, is that the user never leaves the merchant environment. It's only the data that leaves the environment and then is authenticated and validated by the relying party. Okay, so one last point about the demo platform here is it uses the, based on the card that I choose during a checkout, it will dictate a specific scenario from the system. So if I want a frictionless flow, a specific challenge type, WebAuthn, whatever I choose, that's determined by the card that I use. Okay? So we'll start by showing what a first-time user checkout looks like using 3DS. And so because I'm a first-time user, we're going to see a challenge scenario. And the issuer is going to challenge me with a secret, asking me for my bank secret, as well as an OTP, so an SMS OTP. So those two factors are both, the knowledge factor and the device possession factor. So they satisfy SCA compliance, and those credentials will also be used by the relying party to enroll and register the FIDO credential. Okay, so that's what we're going to show you here on this first checkout. So we'll go ahead and start that now. It's a pretty standard checkout flow. We load the cart. We confirm shipping and payment and billing information. So I'll just click through this. And then when I click confirm order here, that's when 3DS authentication will happen behind the scenes. And here is the challenge. So this is the 3DS standard challenge screen from my bank, the issuing bank, and asking me for those two factors, the secret and pretending I have an SMS code sent to me as well. So we'll just go ahead and enter that. And then I'm going to click the checkbox here. It says I would like to bind this device with a FIDO credential. So what that does is basically tells my bank, the issuer, that I'd like to register this laptop as an authenticator. So click submit. And now we'll complete the transaction. So as you see, it says purchase succeeded. I'm still within the merchant environment. And now I have the option to enroll my FIDO authenticator, which is my Touch ID on my MacBook here. But before we show you that, I'd like to go behind the scenes real quickly here and click on the transaction flow. And so here you'll see what happened in the purchase we just did. This is a standard 3DS sequence diagram that you'll see on the left-hand side. And if we scroll down to the challenge flow, you'll see there's a little box here calling out exactly where the FIDO registration request occurred, which is over the challenge flow in 3DS. So there was a challenge request, and then the ACS requested a registration to the FIDO server. And I'll just zoom in here one time and show you this is the data on the right-hand side, so I can actually expand the data elements and see what was returned in each message exchange. And then this data was returned back to the SDK, the USDK, and then persisted by that SDK. So it's now ready to do the FIDO registration. So we'll jump back over to the merchant site. So now we're going to go ahead and proceed with finishing the registration. So when I click enroll, the FIDO Authenticator will prompt me for the WebAuthn, which I'll use my fingerprint here on the built-in Touch ID on the MacBook to complete the FIDO registration of the embedded credential. So there's the WebAuthn dialog. I'll now use my fingerprint. And there's the completed enrollment. So now I have registered the credential, this authenticator, with my bank without leaving the merchant environment. And we can go ahead and look again behind the scenes quickly just to see what happened there. This is actually going to be, it's going to look very similar to the last flow. It's actually a non-payment authentication flow, which looks very, very similar in 3DS, but it does support non-payment auth. And here you'll see in the authentication request and response, in the two yellow boxes there, the first one is the completion of the registration of the authenticator, the embedded credential. And then the second exchange here is actually the ACS requesting a FIDO challenge for the next authentication. So that is basically retrieving a challenge data and then returning that back to the USDK to be persisted by the SDK so that it can be used in the next transaction. So it's basically cached and ready to go for when I want to do a FIDO authenticated checkout. Okay. And so that basically completes the registration process. So now I'm ready to check out using FIDO authentication. And just again to call out the point that, as you saw here, I never left the merchant environment. Only the data, as you see in the sequence diagram, was sent to the relying party, the issuing bank, but the user is still within the merchant page. Okay. So now we'll go ahead and we'll go back to the shop here. Now we've registered, so I can go ahead and show you the FIDO authenticated checkout over 3DS. And one thing to reiterate what Paul mentioned earlier around secure payment confirmation, SPC, the USDK does support use of SPC, so it can support calling a cross-origin credential and staying within the merchant environment. But when SPC is not available, as in this demo here we're showing you, we can use that client API embedded authenticator we just registered to do the authentication in a similar manner. Okay, so in both models, user stays in the merchant environment, the merchant is presenting the authentication, and then the relying party, being the issuer in this case, is actually doing the validation of that. So we'll go ahead and show you one last checkout here, which is now the full FIDO authentication checkout. So again, just going to confirm payment and billing. And then when we confirm order here, when 3DS takes over, we'll see the WebAuthn prompt. There it is. I'll use my fingerprint again. And transaction complete. So again, all within the merchant environment. And if we go one last time to show you what happened behind the scenes, we'll see the 3DS flow. And because we've already registered, that FIDO response data came back in the initial authentication request. It's completed with the FIDO server. And then again, the ACS is requesting the FIDO challenge to be persisted back to the USDK so it's ready for the next transaction. Okay. So that concludes the demo on how to register FIDO Authenticator and do a FIDO authentication over 3DS within the merchant environment. If anyone would like more information, feel free to go to our website and you can click on the big orange box there to request a demo, and we can do a more deeper dive into all of these things you just saw. There's also the option to request a white paper, which goes into much more detail around everything presented today. So, Paul, back to you. Thank you.
Thank you, Jordan. You can just go backwards one last slide. But that basically is our presentation. So I don't know if there's any questions. Obviously, the USDK and CAPI standard proposal is there to create consistency regardless of the checkout, whether it's on app or browser. It's also consistency amongst the data. All of this provides a more secure, more consumer-friendly checkout, and obviously one that's FIDO enables at the top of the line. Were there questions?
Hi.
Come on up.
Great demo, liked it. I have one question though. The way I understand the flow is that, I mean, I like the whole integration with 3DS, but it seems to me like the challenge is I'll have to, if I interact with 20 different merchants over the course of my card's life, I'll have to enroll manually for every one. Is that true, or can the information be shared across merchant?
That is correct, yeah. So there's an enrollment with each merchant. The merchant does, though, control the user experience across each one of those enrollments, but it does occur.
So that's the downside.
Yeah.
Because it's available now, we had to work within the constructs that are available to us. So yes, the downside is I have to enroll, for each merchant that I use a card, I have to re-enroll with my card issuer. The upside is it's available now, and after you do that one-time enrollment, you get that FIDO checkout experience.
But I mean, you could have done a cross-origin FIDO checkout if you were okay with the iframe, right? If the lightbox were to pop up every time. So I guess that's the trade-off, is like, exactly. One-time registration, but then the merchant doesn't get to control the whole experience versus the merchant controls the experience, but then you have that. I mean, I guess it's kind of like, I'm wondering, like, kind of a cost-benefit here for a merchant, because if you share it, chances are that I wouldn't have to go through the enrollment with my merchant because I'm hoping the user already did it previously, but then I don't get to control the experience. So I guess it's like a plus and a minus. I'm not quite sure like where issuers would, or merchants at least, would fall in this, but it's interesting.
Yeah. And SPC, obviously, that's one of the reasons why we support that. SPC solves that problem as it becomes ubiquitous.
So we have an online question, which I think kind of merges with this one. It says, from a merchant point of view, I'd need to add an extra SDK, which adds more app size and complexity, to achieve something that delegated authentication delegated to merchants, so better user experience, allows as well. What's the benefit of using USDK in this case?
So even delegated authentication requires data from the client side, whether it's an app or whether it's the merchant origin. So the USDK is designed specifically to be that one SDK that all reliant parties can use, whether it's a delegated authenticator, whether it's the issuer, whether it's an online guaranteed payment service, whatever the web-based trusted third party is, they can use these instructions and make a call of the single USDK. Otherwise, the merchant, he moved over there. Otherwise, the merchant has to integrate multiple SDKs and manage that as part of their release cycle. And that's just as overburdensome.
So I noticed in your demo, when it actually popped up for the authentication, it said mSIGNA.com on it, right? And you said it was always in the merchant's environment. I just want to be clear that you're authenticating with a different domain than the merchant's, right?
It should have been a merchant front-end demo. This should be the URL that was shown in the WebAuthn box. That's our demo merchant. So it may have had an
no, the
mSIGNA.
actual authentication step was to mSIGNA.com, right?
It's
Yeah.
running. It's
We're
running on
hosting
our.
the
Yeah, it's running
merchant.
on our merchant.
We're
It's
hosting
a
the
demo.
merchant on our .com.
that's-
But
In
the
a real
authentication
world
would be
example,
done
it would be
merchant.com.
on target.com or whatever it be.
okay.
Yep.
Correct.
So,
right.
okay.
That was a very keen observation, though.
Well, that's the key to the whole
Yeah.
thing, right? Right
Yeah.
there. I had something else, but I forgot what it was. I'll catch you in the hall later.
All right.
We should talk. Thanks.
Sure.
We have another one from online.
You missed your turn.
I'll come back to you, Bill. Are there any requirements from any entity to use this SDK?
So obviously the merchants have to integrate it, but that's a huge cost savings because they get all the advantages of SCA, 3DS, FIDO, et cetera. The only burden on the trusted third parties is they have to know the instructions. And you can go to mSIGNA's website and see the instructions, or we can get you a white paper. But if the instructions are exchanged in 3DS, if they go to a client that's not a USDK, by spec, those instructions are ignored. So there's no downside to putting those instructions in your 3DS exchanges. If you're a delegated authentication service, one of the less talked about features is there's no clean interface for a delegated authenticator to interface in with the merchant. And this client API standard proposal provides that clean interface so delegated authenticators or any third party can use these instructions not only through the delegated authority role, but as Simple ID is using to their own issuer app if they want to do login and step-ups.
So is this currently, what's the status of the CAPI and USDK? Is this open source, proprietary? Are you taking it to W3C, EMVCo, FIDO EMVCo working group? What are you doing with it?
Yes to all but the open source. So yeah, we've already shown it in W3C. We're obviously presenting here in FIDO. We've already shown it to the EMVCo 3DS, giving them opportunity to look at it and make comments. The goal is to have it standardized. FIDO seems to be well positioned because of their strength at the client and their strength in the OEM, but we'll figure that out later. But yeah, the goal is we have a proprietary instance right now that you saw that we're selling and is in the market. But the chicken and egg problem is, if I put on the commands, I want more and more groups to be able to answer the instructions. And by going the standardized route, we'll have better pickup on the client side as well.
Yeah, you'll find FIDO a lot faster than EMVCo, I'm sure.
I'm on video, so I'm not going to answer that one.
Yeah. Another one from online. How does your USDK detect a previously enrolled FIDO user?
So we use the native WebAuthn interface. One thing we do is we map a card ID. So we have a card ID mapped to the card being used. So we can map multiple cards if the user's enrolled before. But otherwise, we're not doing anything different. We're using the standard WebAuthn API.
So in our model, there's two possibilities. There's SPC's cross-origin credential, and there's CAPI's embedded credential. If we embedded the credential in that merchant's environment, we're going to know that that credential is in there. SPC gives us a list of all the credentials that are available through cross-origin. So it's not like somebody else could come in and sneak in a credential into the merchant environment that we'd have to become aware of, but we are using the standard WebAuthn and the standard SPC capabilities.
Local storage for our, for Card ID, correct, yeah. Yep.
Cookies are verboten.
Exactly. Yeah.
All right, do we have any other questions in the room? I don't see any, so thank you both very much. Great demo and great talk. Appreciate you coming. Thank you both. Bye.